Okay, medians and altitudes. Aisha said that I can see that angle TVY, this angle here, is congruent to YVU, this angle here. VUX, this angle here, is congruent to XUT, this angle here. She also said that UTZ, this angle right here, is congruent to this angle right here. Because TZ, VY, and UX bisect the opposite sides of each vertex. So by the concurrency of angle bisectors, those are congruent or concurrent. Why is this not correct? Okay. The reason why this isn't correct is it doesn't make congruent triangles. So the problem is when you cut this angle here, this angle and this angle don't have to be congruent because this triangle is not congruent to this triangle. So that doesn't make those angles congruent. Just because it hits the midpoint of the opposite side, if it was a perpendicular bisector, it would make these two congruent. But since it's not perpendicular bisector, if it's just a bisector, then they're not congruent. Okay, so what are we talking about today? Well, we're talking about an altitude and a median. An altitude is a perpendicular segment from the vertex of a triangle to a line containing the side opposite the vertex. So an altitude is a perpendicular segment from the vertex of a triangle to a line containing the side opposite the vertex. Then the median of a triangle is a segment that has its endpoints at the vertex and the midpoint of the opposite side. So an altitude is a perpendicular segment from vertex of a triangle to the opposite side, perpendicular to the opposite side. So this is an altitude. Now an altitude doesn't always have to be on the outside, okay? We could also draw an altitude like this on the inside, okay? So, but if you have an obtuse angle, you're going to have a couple altitudes on the outside, okay? You're going to have a couple altitudes on the outside. A median goes from the vertex to the midpoint, the middle of the opposite side, okay? Altitude goes from the vertex perpendicular to the opposite side. So an altitude is perpendicular to the opposite side. A median goes to the middle of the opposite side, okay? So all three medians are concurrent at a point called the centroid of a circle or a triangle. The centroid of a triangle is where the three medians meet. Okay, so something cool about medians. A median, when all three medians are split at the centroid, the long part is 2/3 of the whole thing. The long part is 2/3 of the whole thing. So if CF was 12, what's 2/3 of 12? 2/3. 8. So 2/3 is 8, 1/3 is 4, that makes 12, right? 2/3, 1/3. Well, how long is CG compared to GF? It's twice as long, right? So if AG was 14 long, how long would GD be? 7. Because what's 14 plus 7? What's 14 plus 7? 21. Is 14 2/3 of 21? Yep, it sure is. So if this was 6, if EG was 6, how long would BG be? Not 3. 12. EG is the short part. GB is the long part. So the long part is 2/3 of the whole thing. So the long part is twice as long as the short part. So the short part times 2 is the long part. Okay? So if this is 18 from J to Q, how long is Q to N? 9. How long is the whole thing JN? 27. Okay, 27. If M is 6, how long is LQ? 12. If KQ is 24, how long is PQ? 12. Okay. All right. So the centroid is called the balance of gravity. So an artist wants to balance triangular pieces of wood on a single point, which makes the piece parallel to the ground. Where should he balance it? Well, he needs to balance it on the midpoint of, or the center of the three medians of a triangle. Okay? So he'd have to find the midpoint of each side, draw a line to the vertex, and then wherever those three lines meet, it would be the median, which is the center of gravity. Okay? All right. So that side is 25. This side is 15. This side is 20. Determine the location of the centroid. Okay? Well, if this is 10, and this is 10, and if it's a right triangle, if this is 10 and this is 15, then we can find it. Okay? I'm not going to worry about that too much. All right. The next thing that we're going to worry about is the orthocenter, which is the point of concurrency of three altitudes. The orthocenter is the point of concurrency of three altitudes. All right. So, here's an acute triangle. On an acute triangle, when you draw three altitudes, the orthocenter is on the inside. If I draw a right triangle, here's one altitude. So let me do it in highlighter here. Here's one altitude. Here's another altitude. And here's the other altitude. Where do the three altitudes meet on a right triangle? Right at the right angle. Okay? So the orthocenter is where the right angle is on a right triangle. The orthocenter is inside a triangle if it's an acute triangle. And if it's an obtuse triangle, because this is 103 degrees, so that makes it an obtuse triangle, the orthocenter is on the outside. That's important to know. So the orthocenter here is right at the right angle for a 90-degree triangle, and it's inside for an acute triangle. Okay? So how do we find the orthocenter here? Well, to find the orthocenter, we have to find the altitude of each side. Now, I did have some problems like this on your homework. I just cut them out just 10 minutes ago. I said, we're not going to want to do those. Those take too long. Kids pound their heads on the tables because they can't figure them out. So we're not going to do them, but we're going to do one right here just to practice so you can see how it's done. Okay? Because I still have a test question that's kind of like this. So you kind of have to know what's going on. Okay. What you would have to do is find the slope from 0, 0 to 10, 5. What's the slope? What's my rise over my run? Well, I rise up 5 and I run to the right 10. So my slope of this line is 1/2. Okay? So, and altitude is perpendicular to that. So what's my altitude slope going to be? So it's 2/1, and then it's going to be negative. So I have to go from this point and go -2 to the right 1. 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 So this altitude, come on, Mr. Bierschbach, draw a straight line. This altitude goes like this. Okay? All right, let's find the slope of this line from 0, 0 to 312. I rise 12, run to the right 3. So what's the slope of this line? Right there. If I go up 12 to the right 3. 4/1. Well, so what's the slope of my perpendicular? -1/4. Okay? So I go, so from, where am I going to go? From here. From here, I have to go down 1 to the left 4. 1, 2, 3, 4. Down 1 to the left, nope. Up 4. Up 1 to the left 4. Up 1 to the left 4. And so on. So it looks like that. Where did they cross? Right there at 6, 6. Because this makes a right angle here. This makes a right angle here. It makes them altitudes. Okay? So 6, 6 is the orthocenter. That tends to drive students crazy trying to do those two homework problems that I had them do over this. So I cut them out, but I understand that's how to find an orthocenter. Okay? All right. So here we go. Let me assign out the homework for this. Boom, boom, boom.